Today I'm going to show you contextual retrieval RAG in action. And we'll also look at how it compares to traditional RAG. This will be a RAG system for a fictional pizzeria called Pups Pizza that offers a wide variety of specialty ingredients, more than what a typical pizzeria might offer. It might be a crazy business model to have hundreds of pizza toppings to choose from, but I'm thinking if I had a pizzeria like that, I would probably want AI automation to help manage all of that. It might at least be able to do things like create new menu items for different locations based on customer feedback or geographical trends. On top of all this, we're going to be running this demo entirely offline using large language models. I just wanted to do this to illustrate how applications can be developed to use large language models locally, especially when proprietary data may be involved. And of course, there is a growing concern around AI and data privacy when you're using these cloud-based services. I've written a Python application that generates the data and allows us to chat with it to illustrate the differences between these two concepts. We're going to take the responses from the chat and see if we can get Anthropic's new Claude Sonnet 3.5. We're going to see if it can figure out which RAG system created which response. As many of you probably already know, RAG, or Retrieval Augmented Generation, is basically a way of providing a large language model with additional knowledge. This is typically knowledge about your product or company offering. Now I have to admit, it's been more difficult getting this video together than I would prefer. Sometimes it can be difficult to keep things from sounding more technical than they actually are, and contextual retrieval RAG is a good example of that, since the concept is pretty straightforward, but the implementations can be as complex as you want them to be. Also, I'm new at creating these videos, and I'm still trying to work out all the best processes for putting these together for you. So without further ado, let's quickly explain what contextual retrieval RAG is all about. For a RAG system, you basically need to break up your data into what they call chunks. And it's basically sections of data. And with contextual retrieval RAG, you basically add more context to it by what they might call metadata to each chunk. Or it's really just additional data to add more context. This additional data might highlight what is in the chunk, or it might highlight relationships to other chunks, so that when a user asks a question, the system can more easily find the related chunks and use those to come up with a better response. So to demonstrate these two approaches, I needed to come up with some data, and this was a branding idea I had for a pizzeria last summer while watching my twin schnoodle puppies playing in the backyard. So I thought this would be a fun concept to create some synthetic data around and use that data to illustrate the difference between traditional RAG and contextual retrieval RAG. I worked with OpenAI's O1 Preview and GPT-4o, as well as Claude Sonnet 3.5 to create this pizzeria data. Ordering and payment information, special diets, allergies, events and catering, and then trend data such as geographical trends, sales trends by location, regional ingredient preferences, seasonal trends, or basically anything I could come up with that would be related to a pizzeria that might help out this RAG system. Just to emphasize that we're running this totally offline, let's go ahead and turn off our Ethernet connection. Let's also start up NVTop on this Linux machine so we can see our NVIDIA GPU utilization during this demonstration. We are using an NVIDIA RTX 3090 here. The 3090 is a pretty good consumer level GPU for doing AI work. Okay, so let's just take a quick look at our code a little bit, and let's just start with the traditional RAG generator. The split into chunks function is used in both implementations, but is probably more critical in traditional RAG. Traditional RAG relies solely on these chunks for retrieval and potentially losing context without additional information. Now, when we do context retrieval generation, we also employ LLaMA 3.2 3b here. Let's look at the create enhanced chunks function. This function combines generated context with each chunk, creating enhanced chunks. It enriches data before indexing, unlike traditional RAG, by including both original text and contextual information. And the way this occurs is we use LLaMA 3.2 3b, and we send it a prompt. Given the following chunk from a document about Pups Pizza, provide a concise context, 50 to 100 tokens, that explains the specific topic or category this chunk belongs to. Example, menu item, pricing, dietary options, etc. Also, any unique or important details about Two Pups Pizza mentioned in this chunk, and then how this information might be relevant to customer inquiries or orders. Or your prompt is probably going to be much different than this, depending on type of retrieval you're trying to get and what type of data that you have. This is just the best example I could come up with here. Okay, so let's go back to our traditional RAG generator and run that so we can produce our chunks and embeddings. Yeah, that was super fast, and we didn't even see anything occur in the GPU. So now you see we have our chunks and we have our embeddings and the face file, which is basically acting as our database in this instance. We can take a look at our chunks, but it's just a bunch of text, just breaking up that document into a bunch of text chunks. And now let's run our context retrieval generator, which is taking a little bit longer, as expected. And we're seeing the GPU jump up to about 70%, and that's because we're running the LLaMA 3.2 3B locally. Even though it's a small model, it still uses some GPU. It's still chunking away. Let's take a look at the differences in size. So our enhanced chunks is 70 kilobytes, and our traditional RAG chunks are only 50 kilobytes. So now we're ready to run our traditional RAG chat. The traditional RAG version retrieves chunks without additional context. It bases retrieval solely on original text content, which may lead to less contextually aware results. Okay, so let's go ahead and ask our traditional RAG chat a question. I heard Two Pups Pizza has a unique monthly special. What's this month's special? October 2024 special. And how does it compare in price to their standard menu items? Also, are there any promotional deals I should know about? Let's run this. The current October 2024 special pizza at Two Pups Pizza is the Fall Harvest. Let's fact check that. Here's our markdown data. And it appears that Autumn Harvest is indeed running from September 15th to November 15th. So that is correct. So that is a seasonal combination of roasted butternut squash, caramelized onions, and applewood smoked bacon on a garlic-infused olive oil crust. This pizza is priced at $22. I'm not going to fact check all of this. Maybe we'll get an LLM to do that. So let's just copy this response and save that into a text file. I'll show you what we're going to do with that in just a minute. Next up is the context retrieval chat. And we're going to ask it the exact same question. Let's take a look at our GPU. Okay, and the context retrieval chat also concludes that the Autumn Harvest is the monthly special. We know that's correct. We're going to copy and save this one off to our responses. So next, let's do something kind of fun. I'm going to ask the new Claude Sonnet to see if it can tell which chat created which response. Traditional RAG or contextual retrieval RAG. So I went ahead and uploaded the markdown content that we've been using for Two Pups Pizza, so it can do its own fact checking there. And I'm also going to include all of the information I have on contextual retrieval, just in case it's been trained on data prior to the release of that paper. Now we're going to get our responses. Well, first let's create our prompt. I'm honestly not too sure how to prompt this, but let's just give it a try. I just wanted to jump in here real quick and mention that in this next section where I write a prompt, I'm using this speech-to-text application that I developed. It uses the OpenAPI Whisper model running locally on this Linux machine. It's a very fast and accurate application and has become one of the most important productivity utilities that I use. If you'd like to know more about this application or would like access to the source, let me know in the comments below. Perhaps I'll do a video about that. You are an expert in determining where text came from in a RAG system. I need for you to look at these two responses and determine which one is more factually correct, as well as tell me which one came from a traditional RAG chat and which one came from a contextual retrieval RAG chat. I've included information on contextual retrieval RAG, as well as the source data that both of these RAG systems used for their retrieval. And let's go ahead and paste in our prompt. Here are the two responses below. Okay, it was correct, and it gives some information on why. In response 1, it says, make specific claims about pricing $22 in comparisons to other pizzas not found in the source data. Response 2 uses the exact name, Autumn Harvest, as found in the source data. So based on how contextual retrieval works, maintaining document context and relationships, I believe that response 2 is from contextual retrieval RAG, which is absolutely correct. It maintains consistency with source document naming, the pricing structure aligns more closely with the general pricing patterns shown in source data. Okay, well, I know this isn't exactly a thorough scientific experiment, but if we were to try it with more questions, we could probably get something fairly convincing. And I encourage you to download this from the GitHub repository and try it out yourself with some different data. Let me know what you think. If you've made it this far through the video, thank you for your time, and I hope you've got something out of this video. We talked about the differences between traditional RAG and contextual retrieval RAG, and how it basically just adds more context. This can enhance the overall response that you're looking for when a user queries your RAG system. It really depends on how you implement this concept, and there are many ways to do that. I've just provided one simple example. Please let me know in the comments below what types of AI-related content you would like for me to cover in future videos. Until next time, keep pushing the boundaries of what you can do with AI.